In this video, I'll be explaining about the distance metrics which are used in KNN. First, let us see what KNN stands for and what it means. KNN is a K nearest neighbor algorithm, is a supervised machine learning method employed to tackle the classification and regression problem. Where classification is a method where the model aims to predict the correct label or a class of a given input data, whereas a regression is a process for estimating the relationship between the dependent variables and one or more independent variables. Why do we need a KNN algorithm? It works by finding the k nearest neighbor to a given data point based on the distance metric. The class or a value of a data point is then determined by the majority or average of the k nearest. Now let us see the distance metrics which are used in KNN. As we know that KNN algorithm helps us to identify the nearest point or the group for a query point, but to determine the closest group or the nearest point for a query point, we need some metric. For this purpose, we use this below distance metric. The first comes the Euclidean distance. This is nothing but the Cartesian distance between the 2 points which are plane or hyperplane. Euclidean distance can also be visualized as the length of the straight line that joins the 2 points which are into consideration. This metric helps us to calculate the net displacement done between two states of an object. So the formula to calculate the Euclidean distance is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So the data points based on the diagram is 4, 4 and 1, 1. Your first 4 is the x1 and next 4 is the y1. And the first one is the x2 and the next one will be the y2. So based on data points and based on the formula, if you calculate, we'll be getting the distance of 4.24. Next comes Manhattan distance. Manhattan distance metric is generally used when we are interested in the total distance traveled by the object instead of the displacement. This metric is calculated by summing the absolute difference between the coordinates of points in n dimension. So the formula of Manhattan distance is given like this. And based on the formula, if we calculate, we'll be getting the distance is equals to 6. So this symbol is known as the absolute value. The last comes the Minkowski distance. Minkowski distance is a metric intended for a real valued vector spaces. We can calculate Minkowski distance only in a normal vector space, which means a space where distance can be represented as a vector that has a length and the length cannot be negative. So to satisfy this Minkowski distance, we have this 4 condition. In the context of the Minkowski distance formula, the p-value represents the order parameter. This parameter determines the type of distance metric being calculated. When p is equals to 1, it represents the Manhattan distance. When p is equals to 2, it represents the Euclidean distance. In essence, the p-value allows you to adjust the sensitivity of the distance calculation to the differences in their individual dimension. A lower p-value tends to prioritize differences along individual dimension more equally, like Manhattan distance, while a higher p-value tends to prioritize a larger difference along any single dimension like Euclidean distance. So these 3 distance metrics are mostly used in KNN algorithm. Thank you.